Hello everyone, this time I want to talk about multi-level selection. I have some questions beforehand. First is what about the performance of multi-level selection with the changes of the comparisons, and does multi-level selection perform better than lofty search? I will make some comparisons between these two algorithms. The domain of this experiment is the reward maze. If a robot reaches the position near the target, the game ends. I get the idea of the multi-level selection from Goldsby's papers, and I also like knowledge search, which is invented by Kenneth Stanley and Joe Lehman. Those algorithms can find a chord in natural selection. The multi-level selection and novelty search are different in group structure. In novelty search, there are 250 individuals in the population. Each group has different individual numbers. In multi-level selection, there are 25 groups and each group has 10 individuals. There are two levels in the multi-level selection. First is the individual level. In each group, parents are replaced after they generate new individuals. Within the group, individuals will make the tournament at the end of the generation. The better individual will occupy the worst one. The second level is the group level. At this point, I take the variance of the individuals' x and y coordinates as the diversity value. I compare the groups at the end of the generation. The worst diversity group will be replaced by the best one. In this experiment, I measure the performance of the robots by recording the accomplishment number of generations. The number of individual comparisons and the number of group-level selections are the variables that I need to change. This graph shows the performance of one-time group selection. With the times of the individual selections increase, the numbers of generations increase. This phenomenon also exists in 3 and 5 times of the group selection. From this graph, individual-level selections interfere the group-level diversity, because in the comparison, a good mutation has a probability to be covered. Individuals in the group will be more similar to each other. The second graph shows the performance of the individual selections. As the numbers of the individual selections increase, the performance decreases. As the numbers of the group selection increase, the performance first increase then decrease. From this experiment, the average performance of the multi-level selection is no better than novelty search. Individual selections counteract with the group selection. When there are many individual level selections, robots are easily trapped in look-optima. The effect of group level selection will be weak, because the best diversity group may also be trapped in look-optima. When those level selections are strong, the situation will be worse, because most of the individuals will be the same in the group, and most of the groups will also be the same.